How's it going, guys, and welcome to a new Creativerse series. In this series, I'm going to be showing you how to use Creativerse's own little machine and signal system. They don't seem to have an actual name for it yet, but we'll just call it machines and signals for now. Okay, so the first thing we're going to want to start off with is that you're going to want to craft one of these guys, which is a wiring tool. It takes stone, coal, and magnetite, and if you are an old player or a new player who hasn't done much in your world, what you're going to have to do is put some coal in your inventory, so collect it. If you've already been playing in a world since before the update that added this, but you haven't used coal yet, you might think something's wrong because you won't be able to access a wiring tool. You just need to pick up some coal, because it doesn't remember what you've done before the update. It doesn't know if you've picked up coal in the past. So just say, put some coal on chest and pick it up again, and you unlock it. Now, once you've got that, you can equip it into your kind of toolbar down here. It's like a third option next to the mining cell and weapon. Now, what we want then is items like the switch and the LED. That's what we're going to be doing for this first one. I'm going to go through each item, each little block, show you what it does, how to use it, and maybe a basic little use of it. So first, the switch is probably the simplest item here. Let's get a little LED here. Now, you might notice with this wiring tool open, we've got a little display. And that display has information. If we point at an item here, it goes, it's a switch, its output isn't connected, its state is false, which means it's not trying to turn anything on. It can be interacted with, and we've got two options. We can break all links, or we can go into its settings. Now, links are these guys, so I can send a signal from this to another block. And if I left-click on him, I get this kind of beam between me and it. And then I have to just go over to this little receive, which means that the LED can receive a signal, and left click. And that connects them, and I can see a blue line going between them, and there's this little graphic here which shows what direction the signal's going in. Now, I can only see that with this gauntlet open and with connections visible. If I press V here, it will hide connections. Press it again, it will show them, and if I go out of the tool, they'll disappear. Now, if I pull this lever, it will turn the light on. So it's quite a simple thing. There is one little thing, if we go into settings, that we can actually mess with this output, and we can get it to output a number. But we'll talk about that in more detail later on. But now, it's connected to that, and its output is the coordinates of... I think this is coordinates of the block which is it's connected to. Anyway, now we're going to move on to one of the other blocks, which is the pressure plate. Okay, here we are. So we've got this pressure plate here, and they're just stone, slab, and magnetite. So a lot of the stuff here takes magnetite. Some of it takes some arc stone. So when you're building stuff, you're going to want to make sure to have plenty of magnetite and a little bit of arc stone. Now, the pressure plate is just that. It's a block you can stand on, and it activates. You step off it, and it deactivates. And we can we can send a signal to it, an item, just like that, just the same as you would anything else. So standard lights up. Now, this will work on other things too. It will open doors. It will turn fans on and off. You know, as any signal will. It's not just for activating LEDs. Any of these signals will cycle any interactable block between its states. So the light can go on and off. A door can open or close. I'm not sure if it works on teleporters. I want to test that at the end of this video somewhere. So yeah, that's just the pressure plate. And if we go into its settings, there's one interesting thing here that I want to show. And that is it's got a reset delay. So you notice that when I was stepping off that plate, the light was going off pretty quickly. Now if I step on it and go off, it's going to wait 5 seconds before it deactivates because I've put an input delay. And that's very useful for some more complex stuff I might get into later. Okay, moving on. Okay, so here we have a slightly more complex thing. We've got our pressure point, plate, and I've just rigged it up to the door to show you. You can step on it, and the door will open. But now I'm just going to go in here, and I am going to break the output link on this, so it links away. What if we want our door open at all times, unless we step on this pressure plate, and want the door to lock in our faces? So that can be done by linking up to an inverter gate, and what an inverter gate does is it takes a true signal and inverts it to a false signal, or it takes a false signal and inverts it to a true. So I take that signal there and I forward it on, and if I step on this, the door will close. Because it's going, okay, I'm receiving a true signal, and I'm going to invert it. And close it instead. So there you have it, the inverter signal. So if you have, this can be used with some very complex designs later on, but for now it's really useful if you just want very simple things like this to happen. So it just receives a certain output and outputs the opposite of what it receives. Whatever it receives, it outputs the opposite. So yeah, that's basically what it does. It's quite simple, really. Okay, here we have another machine called the flip-flop gate, and it's another kind of basic signal processing gate in that when we send a signal to it, rather than just sending it on after a delay or sending it on inverted, what it does is it sends it on, but then it toggles itself to that signal, and then if you send another signal, it toggles back to the reverse. So let's just show it in action, because it's a little bit difficult to explain abstractly. If I step on the pressure plate once, it will open the gate, the door, but keep it open, because it continues to send a true signal at this point. It gets turned onto a true signal, and it won't go back to false until this button is pressed again. So if I step on the pressure plate again, it will then go back to a false signal. So it's basically a toggle switch that can be used for something like this. And this could be very good for like an airlock system or various traps and all sorts of things. One thing it's very good for is just advanced circuits of various kinds. This is one of the things which people loved using these in Redstone in Minecraft a lot, using pistons, but here we've got it in a nice handy block, so it's quite convenient. Okay, here we have the delay gate, which I mentioned briefly in my previous little segment. Now, what this does is it takes a signal from something like a pressure plate and then sends it on after a delay to another item like a door. What we've done here is I've selected the delay to 4, which means 4 seconds. Now we can stand on the pressure plate, and after 4 seconds, the door will open. Like so. Now, one thing to keep in mind is that there is a little slight bit of odd behavior, which I'm not sure if it's intentional right now. And that is if you press the plate for only a little bit and come off, we'll see if it does it. Sometimes the door doesn't open. Like that. It makes a noise, if you heard that there, of it opening, but it didn't actually open. So, it will do it, however. If you stand on the pressure plate for the entire time that you wait, it will open normally. So just keep that in mind when you're using it. And of course, because the pressure plate sends a false signal after you step off it, the door will close again after the same delay after you deactivate it. But if we attach this guy too, then we can pull the lever, and it will work like normal. Okay, onwards. Okay, guys, this is where things get a slight bit more complicated. This is called a logic gate, and what this can do is it takes 2 inputs, it does an operation on them to see it and to see what output it should put out. So say if we want to, I'll go back into that there, do an AND calculation, that means it will only output a true signal if both the first signals going in are true. So if we attach these guys into the receive nodes here and hook that up to the door, then what we've got to do to activate it is flip both of these levers here. Then the door will open. flip one of them back and it will close instantly. Now, what we can do is set it to all sorts of other calculations. So if we did OR, then either lever should open it. Oh, that's not working. Okay, wait a minute. Oh, I didn't save. Sorry, that's a thing. Okay, yes. Remember to save when you make a change in here to these settings. You need to save. I just got tripped up by that then, so it's an easy thing to forget. Okay, so flip that and it will open. Flip it down, it will close. But I can flip this one as well. So it can be opened by either. That's handy for if you want a door that can be opened by a lever on either side, or a pressure plate. It'll work with anything. Now, we could do... we can have it so that it will open if either one of these is true, but not if both are true. So I can open it of this one, and I can open it of this one, but it will close again if I have both open. And this seems to be being a bit weird. Oh, yeah, see, I forgot to save again. That's the nightmare. So yeah, it will close if both are true, but it will be open if either one is true. So that's called a XOR calculation. So let's go to NAND. So this will go if input 1 is false. Sorry, no, I got that wrong. Say it will output only true if it will be like the opposite of AND. So it will output false if both of these are true. So it will be open if they're turned off, open if one's turned off, but it will close if both are turned on. Now, let's go on to the next. NOR. Outputs true only if input 1 and input 2 are both false. So that's also kind of related to that one, where if I turn these both off, it will output as true. Now, XNOR. Outputs true if both input 1 and 2 are the same value, true or false. So this is another one related to that. Doesn't matter if it's true or false as it is now, but if they're different, it will be closed. So it just needs a matching type. Okay, so that's the logic gate. That might seem a little bit overwhelming, but if you want to use one of its functions, there's a little tooltip here that can remind you which one does what. So that's very, very handy. Okay, moving on to the next one. Okay, so here's two new blocks, the number pad and the number comparison gate. Most of the time when you use one of these, you're going to be using one of the other somewhere as well. So the number pad enables you to put in a code, which it then sends on to the other. And unlike it being a true and false code, this is actually a number. So we put in like 1, 2 here, 12, it will output 12. And what this comparison gate does is it compares an input with a number you store inside it. So if I say 12 and leave on comparison equal here, so if the number it receives is equal to 12, then it will send on true. So if we just link these guys up and then link that onto the door, then send 12. Whoops, did I remember to save it there? I did. Whoops, I've sent it onto the wrong link. Sorry. What I need to do is just break this connection briefly and link it over to this guy, because that's what it wants to be connected to. Now, if I just go here and press 12, boom, the door opens. And press 12 again. And, oh yeah, actually it consistently sends out a true signal after that. If I send out another one, I think it will close. Yes, so it'll go, oh no, that doesn't equate to it. Better cancel the signal. And if I press like 1, now it won't send on anything. Now, if I go, okay, so it's got to output if it's not equal. So currently this is outputting 1 to it, so it'll go, okay, it's not equal, so it's open. If I output 12, it's going to say it's equal, don't open. Output 1 again, it's going to open. And the same for all of them. You'll notice the logic of these, it's a similar kind of layout to the logic of the other ones, so there's no need to go through all of this, as there is less than or equal, greater than or equal. So those are all fairly simple, and that is how you use the comparison gate along with number pads to open doors. Now, there's going to be a lot more to the ways you can combine all of these guys, but now you have the very basic kind of function of each individual block now. The magic is in how you combine all of that, and I plan on making more videos over time on little contraptions that I've come up with, and also on contraptions that other people have shown me, because I'm quite sure people will be able to build some really cool stuff in this game. So if you have a cool little machine design that you want to show me, or perhaps want me to make a video about, please do let me know, because it would be wonderful to see what you guys can come up with. Okay guys, I hope you found the video useful and enjoyable, and I will see you next time. See you later guys.